and at the end of the day, we are going to have 106 gram per mole. And the concentration of the base has been given in the question to be concentration in mole per dm cube. Mole per dm cube has been given to be 0.1 mole per dm cube. So, since we are asked to look for the concentration of the base, which is P, so concentration in gram per dm cube of the base will automatically be concentration of the base. What is the concentration of the base from the question? 0.1. What is the molar mass of the base? 106. So when we multiply this, we are going to have 10.6 gram per dm cube. Therefore, the concentration of the base in gram per dm cube is 10.6. Question number 2. Solution A is a solution of an acid with formula H2X containing 2.45 gram in 500 cm cube of solution. Solution B contains 3.90 gram of sodium hydroxide in 1 dm cube of solution. If 25 cm cube of A is completely neutralized by 24 cm cube of B, calculate 1. Mass concentration of A in gram per dm cube. 2. Molar concentration of B in mole per dm cube. 3. Molar concentration of A in mole per dm cube. D, which is Roman figure 4, the molar concentration of H or molar mass of H2X. From the question, the H2S is given as 2.45 gram in 500 centimeter cube. Solution B, which is the solution of the base, is sodium hydroxide, which is given in 3.90 gram in 1 dm cube, which is a standard solution. The volume of the acid is also given as 25 cm cube. The volume of the base is also given as 24 cm cube. Then the question asks us to calculate the mass concentration of A in gram per dm cube. This is the mass concentration of A, but here it is not standard, because before it can be standard, it must operate on 1 dm cube, which is the same thing as 1000 cm cube. And in order to do that, answer to question Roman figure 1 of 2 is 2.45 gram requires 500 cm cube. To calculate the concentration of H2X, which is the acid, in gram per dm cube, that means it has to operate on 1000 cm cube. We want to determine the mass at that point. So here, let the mass be X. So if we cross multiply, we are going to have 500x equals to 1000 times 2.45 gram. Then, dividing both sides by 500, you're going to have 1000 times 2.45 over 500, which is equal to 500 here 1, 500 here 2. That is 0, 9, 0.4 gram per dm cube. So here, this is the concentration of this acid in 1 dm cube, which is a standard solution. Answer to Roman numeral 2, which says molar concentration of B in mole per dm cube. Remember that concentration of B in gram per dm cube has been given in the question to be 3.90 gram per dm cube. Recall that concentration in gram per dm cube is equal to concentration in mole per dm cube times molar mass. So what is the molar mass of sample B, which is sodium hydroxide? Sodium hydroxide. Molar mass of sodium hydroxide. Molar mass of this sodium hydroxide is, sodium is 23, plus oxygen is 16, plus hydrogen is 1. So that is 40 gram per mole. Okay? Now, our interest is to calculate the concentration of this sample B, which is sodium hydroxide, in mole per dm cube. Concentration in gram per dm cube has been given to be 3.9 gram per dm cube. This is what we are to calculate, concentration in mole per dm cube times the molar mass, which is 40 gram per mole. If we make this solve the formula, we're going to have concentration in mole per dm cube to be equals to 3.90 gram per dm cube divided by 40 gram per mole. So in that situation, it will give us 0.0975 mole per dm cube. So this is the concentration of sodium hydroxide, which is the base, in mole per dm cube. 0.0975 mole per dm cube. Roman numeral 3 for question 2. Molar concentration of A in mole per dm cube. We resolve by using the neutralization formula of CaVa over CbVb equals to Na over Nb. The reaction is H2X plus sodium hydroxide. Here we have two of these, that's Na2X plus water. This is a neutralization reaction where an acid reacts with base to give you salt and water. So here it can be used that the Na, the number of mole of acid is 1, the number of mole of base is 2. The volume of the acid has been given in the question to be 25 cm cube, and the volume of the base has also been given in the question to be 24 cm cube. Our interest is to look for the concentration of A, which is the acid, in mole per dm cube. Ca is our interest. And we have calculated our Cb to be 0.0975 mole per dm cube in the first question. So, imputing all these parameters, then we have Ca times Va, which is 0.0025 dm cube, by dividing this by 1000, divided by Cb, 0.00975 mole per dm cube, times Vb, which is 0.0024 by dividing this by 1000 to convert it to dm cube is equal to number of mole of acid, which is 1 from the question, over number of mole of the base, 2. Our interest is to make Ca the subject of the formula, and if we do that, it will be Ca equal to 0.0975 times 0.0024 times 1 divided by 0.0025 times 2. And we do this arithmetic, it will amount to the concentration of this to be 0.050 mole per dm cube. Therefore, the concentration of the acid, which is A, is 0.50 mole per dm cube. Roman figure 4 of question 2. The molar mass of H2X. Molar mass of H2X. You have concentration in gram per dm cube equal to concentration in mole per dm cube times the molar mass. Our interest is to look for this molar mass, and if we are to look for this molar mass, we must know this and we must know this. From our calculation earlier, concentration in gram per dm cube of H2X is 4.90 mole per dm cube. Then gram per dm cube. Then the concentration in mole per dm cube is also